Hello ladies and gentlemen, and welcome to part 3 on our custom splitter tutorial. In our previous tutorial we made items go in through an input conveyor and out through an output conveyor, and before that we managed to get our merger cube into the world. And today we are going to make it so that our splitter will round robin and solve a few logic issues that a lot of people do come across. That's really easy actually. So the first thing that we're going to do is we're going to jump into our building here and leap over to the viewport. Okay, so here we go with our cube again, and as you can see we have our input and our output, and we need to add new inputs and new outputs. Okay, so I'm going to go into perspective top. Okay, I'll make sure that our root component is selected. You can see the outline of the cube here. This is a wireframe view. I can go to lit like that, but this from the top just gives us a better view of our conveyor connections. So I'm going to click on the root component here, and we're going to add a new factory connection. I'm going to place it there. Let's drag this out and give that a rotation of 90 degrees. Okay, and rename this to be output 2. Unreal. Rename output 2, output 2. Okay. And then we are going to obviously select that to be output and tick the M forward peek and grab. And then we're going to do the exact same again on the other side. So we're going to do factory connection. And we're going to drag that up to there. And then this one's going to be rotated by -90. We're going to call this output 3. Rename output 3. Set it to be an output and M forward peek and grab. There we go. So now we have input, output, output, and output. Okay. And click compile. And that's our merger done. Okay, for outputs. Now what we need to do is we need to do some logic. Okay, so in the last video we made this this bit of logic here on the factory grab output. So what it says is for every output it's going to fire this tile here. This is going to be called, and for every output, every factory tick, we're going to get one of the outputs in connection here. Okay, so I'm just going to quickly delete that from there. And the first thing that we need to do is we need to determine a counter. Okay, so what I'm going to do is I'm going to click variables, add variable, and I'm going to call this counter. Okay, and I'm going to change the type of this counter to an integer. The next thing that I'm going to do is I'm going to show advanced on that counter variable. I'm going to click save game. What this does is it means that this counter is going to be included in the save game data for our merger. So our counter will be persistent with saves. Okay. Now, right now we're saying, hey, if input 1 is connected, then, okay, I've deleted all the other code. So the next thing I need to do is I need to know whether connection, well, what connection is needs to be. And so I'm going to grab all of our outputs, okay, and I'm going to also grab our counter. Oops. Grab our counter, get counter there. Right, I'm just going to stack these up beautifully, like so. Okay. And I'm going to use a select case. So I'm just going to drag out from there, type in select, and use the select at index. So the way the select at index works is it takes in an integer and then it will output one of several items based upon that integer. excuse me. So I'm just going to link counter to our index there. I'm going to click add pin. So now we have option 0, 1 and 2. Okay. So what this is essentially saying is that if counter is equal to 0, then return value is going to be output 1. If counter is equal to 1, then return value will be output 2. If counter is equal to 2, then our return value is going to be output 3. Okay? The next thing we need to do is we need to know if connection and return value are the same. So I'm just going to drag down through here and do an equals. Okay? And I'm just going to link those two. So now this boolean here will be true when connection is equal to the return value of our select. The next thing I want to do is make it so that this branch will only be true when A, input 1 is connected, and B, when our select value here matches connection. Okay, so where we're going to do that is using an AND. So I'm just going to do boolean and boolean. Okay, I'm going to link these up like so. So now, if input 1 is connected and connection is equal to return value from select, okay? The next thing we need to do is we need to know whether or not this function has been fired, because at the moment, this function will be fired for every connection, well, for every output, right, that we've ticked the output, that we've ticked this box for, okay, and forward peek and grab. So every factory tick, this function will be called for output 1, 2 and 3, okay? However, it will not be called if the output is not connected. So if output 1 is not connected, output 1 will not be called during this factory tick, and that will cause our counter to jam when we add the logic for our counter. The same if the output is full. If the conveyor belt for output 1 is full, then output 1's factory grab output will never be called. This function will not be called for output 1. Again, our counter will be jammed. And the way we're going to do, we're going to solve this in just a second. Let's quickly add the logic for that counter, right? So we're just going to quickly grab the counter, get counter here, and we're just going to use increment in. So that's going to, this tile here will add 1 to the value of our counter. Okay, there we go, and there we go. So now the way this is going to work is every time that the input 1 is connected and the output is equal to connection, then our counter is going to be increased by 1. However, this function doesn't do anything at the moment because we need to add our grab input, right? But if our but with that, if our outputs are empty, or if our outputs are not connected or they're full, then we're just going to jam. So we need to solve that. The way we are going to solve that is by adding in a new variable, which is going to be a boolean, and I'm going to call it exec. Okay, it just means, give me a second, sometimes it does that. Okay, set it to a type of boolean. Okay, and all I'm going to do is just put set exec here. If it's true, then we're going to set exec to be a value of true. So the boolean exec is going to be used to determine whether or not this function has fired successfully based upon the value of counter. Okay, so then all we got to do now is just do our we just got to increment the value of counter. Oh wait, hang on, no we don't. We got to now grab our item. Okay, so I'm going to do our factory grab input, well, factory grab output for input 1, like we did last time. Okay, and then we just need to add a branch in here because we need to know if an item's passed through. So the way we're going to do that is, oops, link that to there. So if return value from factory grab output is true, okay, so if an item has been passed, well, if an item has successfully been grabbed from our input 1, okay, we need to add 1 to our counter. So I'm going to get counter, and I'm just going to do increment int, so it's going to add 1 to our counter. So if it's true, there we go. If it's false, then we ain't going to do nothing, okay? If it's false, then we're going to hold our counter and wait for an item to actually pass through. So I'm just going to drag this to our finishing node, and I'm just going to relink out item, offset beyond, and return value. There we go. Okay. So now this is still going to jam, because right now, even though we've put the exec value in to know that this function has successfully been called during this factory tick, we are not doing anything with it. Okay. So we need to do something with that value now. So I'm just going to quickly compile this and go into our event graph. Here we go. So our event graph, just going to delete everything from in there, and we are going to use the collect input event. Okay, event factory collect input. So this gets called after we've done our well, this gets called every factory tick, and it basically gets called after our outputs have been fired. Okay, so after our outputs have tried to push an item out of them. So the first thing we need to do is we need to know whether or not the value of exec is true. Have we executed the correct output? Has the output fired, right? That's what exec is recording. So I'm just going to put a branch in here. Okay, value to there. Excellent. Right. If it has been fired, then we're going to need to set exec back to false. Okay, so right here we're saying if exec is true, then we're going to set exec to be false again. Okay, if it's false, if exec isn't true, then our conveyor is jammed, because our current selected output is either full or it's not connected. Okay, so to solve that, what we're going to do is we're just going to add 1 to the counter. So we're going to grab a counter, and we are going to increment it by 1. Oops, wrong. I need increment int. There we go. Okay, so if exec is true, set exec to false. If exec is false, then we're going to add 1 to the counter. Okay. The next thing we need to do is know if our counter is bigger than 2. Okay, because our counter's maximum value is 2, and if it's bigger than if it's equal to 3, or it's bigger than 3, we need to set it back to 0, so that we'll go from output 3 back to output 1. Okay. So for that we need to get counter. Okay, and we need to determine if it is bigger or equal to, and I'm just going to put 3 here. Okay, and then we're going to take that boolean output and we're going to slap it onto a branch. Okay, and then we're just going to link our set and our increment to it. There we go. And let's make our code a little bit neater here. There we go. Okay, so here now we need to determine if the counter is bigger than 3, we need to set it back to 0. So that's simple enough. If counter is bigger than 3, then set to 0. Okay, and that's it. That is quite literally everything done. We don't need to do anything more apart from press compile. Okay, and click our packet. Okay, so we'll be back when it's time to test this in game. Okay, so I'll see you in a few minutes. Okay, so here we are now. We are in Satisfactory with our updated mod, and as you can see, we now have 3 outputs and 1 input. So let's go give this thing a test. I'm going to place it down. We are going to get ourselves a storage bin. Pop that there. And we are going to obviously need 4 conveyors. So there's 1 conveyor, there's 2 conveyor, and there's our 4th conveyor. So let us grab 6 items and shove them in. So hopefully what we will see is, if I put the items in, that we should have 2 items go through to each output now. So there's 1, there's 2, there's 3, there's 4, 5, and 6. Excellent. So let's see what happens when we only have 2 conveyors connected. It should still work. Let's grab 2 items. Watch them go through. There's 1, there's 2. Oh wait, we need to add more items. Let's add a bunch more items, shall we? And watch them go through. Well, you should go back to here, then to here, then to here, and then to here. Excellent. And if one of the conveyor jams, should continue. So this one now should, because that conveyor there is jammed, always receive an item. Let's go shift these items back in, store all, and we should see the plates appear on this conveyor still. Excellent. And that, my friends, is a successful 3 output round robin merger. There you go. Let me know in the comments if you've got any ideas for other tutorials or stuff you want to see. Don't forget to check out the Satisfactory Modding Discord, where there's a bunch of guys who are happy to help you. And yeah, take it easy, folks. Bye.